Hello dear children, welcome to maths class. Today we are going to do the problem in page number 117. Question, in the picture, okay, in the board you can see a picture. In that picture, the vertical lines are equally spaced. Vertical lines are equally spaced. Prove that their heights are in arithmetic sequence. What is the common difference? Okay, if it is an arithmetic sequence, we know that there exists a common difference. So, here we have some vertical lines. See, this angle is equal to 40 degree. Then, if we draw triangles like this, what about all these angles? We did this in the chapter arithmetic sequence. Do you remember what all these angles? Yes, all these angles are equal to same inclination as here. So, all these angles are equal to 40 degree. Okay, all these angles are equal to 40 degree. Now, I am going to name these points. Okay, let these points, this is A and this is B, this is C and this one is D, this is E and F, G, like that. Okay, and the distance between the lines, all these vertical lines are equally spaced, and the distance between lines, we can take the distance between the line as D. Okay, all the lines are equally spaced and we take that distance as D. Okay, then here I am going to take the height of the first line, the first vertical line be H1. Okay, and height of the second line, that is this line, that is H2. This is H3 and this is H4, like that. Okay, so these are the height 1, height 2, height 3, height 4. And we need to prove that these lines are in arithmetic sequence. That means first second minus first is equal to third minus second. Similarly, the fourth minus third, like that. Okay, that means there exists a common difference. There should exist a common difference. Then how do we prove this? For that, here I am going to consider this triangle ABC. Okay, this triangle ABC. In that triangle, we know that this angle is equal to, yes, that angle is equal to 40 degree. This angle is equal to 40 degree. Then, in this triangle, what about this height? This is the increment in height, right? This is H1 and this is H2. And H1 and H2, the difference is this length BC. Right? This length BC is the difference between H1 and H2. Then, how do we find this BC? By taking which ratio we can calculate this BC? We have this distance, that is D. Okay, that length is common to all. So, we take this distance as D. Then, we need this BC. Then, this is adjacent to 40 and this is opposite to 40. Then adjacent and opposite. So which ratio is that? That is tan ratio. Using tan ratio we can find out this BC. Okay, that is tan 40. What is tan 40? Yes, tan 40 is equal to opposite side. Opposite side is BC by adjacent side AB. Okay, opposite side by adjacent side, that is equal to BC by AB. So here we have, yes, BC by, what is AB? What is this length? That is equal to D. So we have BC by D. So tan 40 is equal to BC by D, or this BC is equal to, yes, BC is equal to, just cross multiply this tan 40 and D. That is D tan 40. Okay. So we have BC is equal to D tan 40. So this length is equal to D tan 40. Then next I am going to consider this triangle CDE. Okay, that is also a right triangle with one angle 40 degree. Then what is tan 40 here? Yes, tan 40 is equal to opposite side by adjacent side. What is the opposite side? Yes, if we consider the triangle CDE, what is tan 40? Yes, tan 40 is equal to ED by, yes, ED by CD. Okay, ED by CD. And what is CD here? Yes, CD is D. So we have tan 40 is equal to ED by D. That is, this length ED is equal to, yes, just cross multiply this two, that is D tan 40. Okay, so we have this distance BC is equal to D tan 40. This distance ED also equal to D tan 40. Then can you guess what is this distance? Yes, that is also equal to D tan 40. Why? Because if we take this angle, we have this angle is equal to 40 degree. And if we take the tan of 40, we have GF by EF. Okay, then GF is equal to D into tan 40. Okay, so we have all these lengths are D tan 40. So we have the first one is H1. Okay, H1 is H1 itself. Then what is H2? Yes, H2 is equal to H1 plus this length is equal to D tan 40. So H2 is equal to H1 plus D tan 40. Okay, then what is H3? Yes, H3 is equal to, this is H2, right? This length plus D tan 40. So H2 plus D tan 40. Then what is H4? Yes, H4 is equal to H3 plus D tan 40. Okay, so we have a first term and here we added a common number. Okay, first plus common number gives second, second plus common number gives third, third plus common number gives fourth. That means there exists a common difference. So we can say that this H1, H2, H3, H4 forms an arithmetic sequence. Okay, this H1, H2, H3, H4 forms an arithmetic sequence. So that is the proof. Then what is the common difference here? Yes, we can see that first plus common difference is equal to second, second plus common difference is equal to third. So here the common difference is equal to, yes, D tan 40. Okay, D tan 40 is the common difference. Okay, now we are going to do the last problem in the exercise. Question is, one side of a triangle is 6 centimeters and the angles at its ends are 40 degree and 65 degree. Calculate its area. This is our question. Okay, so here we have a triangle. Okay, this is our triangle and we have this side is equal to 6 centimeter and angles at its ends are, yes, one angle is equal to 40 degree and other is equal to 65. Okay, this is equal to 40 and this one is equal to 65 degree. We need to calculate its area. Okay, how do we find area? Yes, we know that area of a triangle is half BH, right? Half into B into H. Yes, half is the, what is B? B is the base of the triangle. B is the, what is B? B is equal to 6. Then what about H? It is not given. So first we need to find out this H. Okay, that is the perpendicular height from the third vertex to the base. So this is the height of the triangle and it is perpendicular to the base, right? Then here I am going to name this triangle as ABC and this point as D. Then by drawing the CD, we split the big triangle into two small right triangles. One is triangle ADC and other is triangle BDC. Okay, two right triangles. Then how do we find area or how do we find this height? Yes, let us find out. Yes, to find the height of the triangle, here we are going to use the tan ratio. Okay, how do we find that? See, here we have a total length is equal to 6 centimeter. And if I take this length as x, okay, this length as x, what will be this length? Yes, total length is equal to 6 centimeter up to this x centimeter. Then what will be this length? That is equal to, yes, 6 minus x. Right? 6 minus x. If this length is equal to 2 centimeter, what about this length? That is equal to 6 minus 2. Okay. So here we take this length as x and this length is equal to 6 minus x. Then if we consider the triangle ADC, how do we find h? Or what is the relation or which ratio is used here? Tan ratio, right? So what is tan 40 here in triangle? Yes, in triangle ADC, what is tan 40? Yes, what is tan 40? Tan 40 is equal to, yes, this height. Okay, that is opposite side. This is the opposite side by adjacent side. That is opposite side is h and adjacent side is x. Okay, so we have tan 40 is equal to h by x. Okay, tan 40 is equal to h by x. From this, what is h? Yes, just cross multiply this two. Then we have h is equal to x tan 40. Okay, x tan 40. That is our height. From the first triangle ADC, we have h is equal to x tan 40. Okay, we put this as equation number 1. But we don't know what is x, right? So we just take h is equal to x tan 40. Now, yes, now I am going to consider this triangle BDC. This one is also a right triangle and one angle is equal to 65 degree. And if we take tan of the 65 degree, what is the ratio or what it is? Yes, that is tan 65 is equal to opposite side by adjacent side. That is equal to h by, yes, 6 minus x. Okay, h by 6 minus x. So here we have, yes, from this equation, what is h? Yes, h is equal to, just cross multiply this two. What is that? That is equal to, yes, tan 65 into 6 minus x. Okay, tan 65 into 6 minus x. Then, so we have, this is equation number 2. So from the first equation we have h is equal to x into tan 40. Okay, and from the second equation we have h is equal to tan 65 into 6 minus x. Okay, both are h, right? Both are h. X into tan 40 is h. Similarly, tan 65 into 6 minus x is also equal to h. So, from 1 and 2, we have, yes, h and h are equal. That means x tan 40 and tan, yes, 6 minus x into tan 65. Both are equal. Okay. X tan 40 and 6 minus x into tan 65, both are equal. Now we just solve this equation. Okay, let us solve this. So here I am going to rewrite this equation, that is x tan 40 is equal to 6 minus x into tan 65. Okay. So just expand this. So we have, yes, 6 minus x into tan 65. That is equal to, if we expand or if we open this bracket, we have 6 into tan 65. 6 into tan 65 minus, yes, x into tan 65. Okay, x into tan 65. So here we have, yes, I am going to rewrite this equation again, that is x tan 40 is equal to 6 into tan 65 minus x tan 65. Okay, now I am going to move the variables on one side and numbers on the other side. Okay, for that, yes, here I am just moving this x tan 65 to this side, left hand side of the equation. So what we have, yes, here we have x tan 40. Okay, and here we have minus x tan 65. So if we move this minus to the other side, we have, yes, x tan 65. Okay, and here we have, yes, 6 into tan, yes, 6 into tan 65. Okay, 6 into tan 65. Then in here we have x is a common factor, so take that common x outside. Okay, take that common x outside, then inside the bracket we have tan 40 and here we have tan 65. Okay, so x into tan 40 plus tan 65 is equal to 6 into tan 65. Okay, now we need this x only, right? X. So what is x? Yes, x is equal to, just move, this is x into tan 40 plus tan 65, right? So if we move this to the other side, that is equal to, yes, x is here, yes, into tan 40 plus tan 65, go to the other side, it become divided by. Okay, so we have 6 into tan 65 divided by tan 40 plus tan 65. Okay, so we have x is equal to 6 into tan 65 divided by tan 40 plus tan 65. Now we just substitute the value of tan 65 and tan 40 here. Then we will get an answer. Okay, so tan 65 is equal to 2.1445. Okay, so we have x is equal to, yes, 6 into 2.1445 by, yes, what is tan 40? Yes, tan 40 is equal to 0.8391. Okay, 0.8391 plus tan 65. What is tan 65? Yes, tan 65 is, yes, we already wrote it, 2.1445. Okay, 2.1445. Now we need to simplify this. Okay, first add the denominator. We have, so we have 6 into 2.1445 is equal to 12.867 and 0.8391 plus 2.1445 is equal to 2.9836. Now divide this 12.867 by 2.9836. Then we have x. So we have our x is equal to, yes, x is equal to 4.3126. Okay, in the beginning we have an equation. What is that equation? Yes, h is equal to x tan 40. Okay, h is equal to, yes, this is our equation. H is equal to x tan 40. Okay, we need this h, right? So just substitute x here. What is x? That is equal to 4.3126 and substitute the value of tan 40 also here. Then we will get the height of the triangle. So x is equal to 4.3126 into tan 40 is equal to 0.8391. Then we have, yes, if we multiply these two, we have 3.62. Okay, 3.62. That is, the height of the triangle is equal to 3.62. So we have base and the height of the triangle. Okay, if we have the base and the height, then we can calculate its area, right? So we have B is equal to 6 and H is equal to 3.62. Then what is area? Yes, area is equal to half BH. Okay, that is equal to half into what is B? B is equal to 6 and what is H? H is equal to 3.62. Okay, just cut this by 3. So we have 3 into 3.62. That is the answer. Let us calculate it. So that is equal to 10.86. It is approximately equal to 10.86 square centimeter. Okay, see children, this question is an important question. Okay, important question. Says frequently asking 5 marks question. Okay, so if you have any doubt, you can call me. Okay, so it's time to wind up the class. Thank you children. Thank you.